In this video, we're going to discuss measures of center. Let's begin. We're going to specifically focus on mean and median in this one. So data can be described by its center, which refers to the mean or the median. So it's the number that's in the middle. And mean is sometimes referred to as the average. So we're going to start off by talking about the mean or the average. We're going to take a look at this example. So pretend you own 3 gumball machines and you put them all over on campus, on the school campus, and you put them in different places. And by the end of the day, you want to make sure that each of the machines has the same amount of gumballs. You don't want one machine to be completely full while another one to be nearly empty. So at the end of the day, you want to even out the number of gumballs. And so what's the way we can do that? How can we move the gumballs around to create an equal number of gumballs in the machine? Well, one way to do it is to just kind of move gumballs around until it looks about even, and then you count it up and make sure it's all good. The other way to do it mathematically, to do it in a more exact fashion, is to find the mean or the average. So we're going to add all these gumballs up, and you're going to find out how many total gumballs you have. Now, once you have the total number of gumballs, how many machines do you need to divide it into? Well, you've got 3 machines, so you're going to take that total number and then divide it by 3. So how many total gumballs do we have? Well, it's 11 plus 5 plus 8, which is simplified as 24. And then we need to divide it into your 3 gumballs, 3 gumball machines, which means that 8 gumballs should go in each machine. So you're going to take a couple out of here and you're going to move it into there. The mean can also be thought of as determining the fair share of gumballs in each machine. So the mean is also known as the average, as we said before. In order to find the average or the mean, you need to find the number of pieces of data, and then you need to divide by the number of pieces of data. So let's do some examples to clarify. So let's say you've got gumball machines with 16, 12, 13, 8, and 11. Looks like you're becoming a gumball tycoon now with 5 different machines. So what I need to do is I need to add up all the gumballs I have. 16 plus 12 plus 13 plus 8 plus 11. And we know we have 5 gumball machines because there are 5 pieces of data up here. So we're going to divide that by 5. So when we add up all our gumballs, we've got 60 of them. We're going to divide that by the number of machines, which is 5. And so each gumball machine should have 12 at the end of the day. Let's do another example. We can't be talking about gumballs this time because we have 5.6 and 7.1 gumballs. So we don't have partial gumballs. So let's try to divide pounds of sugar, let's say. So you've got all these people who need their sugar, and these 6 people, and you want to divide it evenly. So what we're going to do is we're going to take all these pounds of sugar, 5.6 plus 7.1 plus 9.9 plus 6 plus 8 plus 3.4, and because there are 6 pieces of data here, we're going to divide it by 6. And turns out that the total pounds of sugar is 40. We're going to divide it by the 6 people, and it looks like we get a funky decimal, 6.666 repeating. We're going to round that up to 6.7. Now, this squiggly equal line is not a mistake. The squiggly equal lines means approximately equals. So 40 divided by 6 approximately equals 6.7. All right, let's discuss median now. The median is another measure of center, which is the middle of data when it is organized from least to greatest. Determine why someone would claim that 9 is the center of the data below. Why would someone claim that 9 is the center of the data? That seems kind of odd because there is no number 9. I mean, it goes right here, but there's no dot above it. So, I mean, that could be the average in this graph, but let's pretend let's go back to gumball machines, and let's pretend you've got all these gumball machines, 1, 2, 3, you count up all the dots, you've got 14 gumball machines. One of your machines has 3 gumballs, another machine has 5, 2 of your machines have 6, 2 of them have 7, and so on and so forth. So how do you find the median? Well, you order the data from the least to the greatest, and then you determine the middle of the data set. Now, the middle number of the data set is like if you took all your gumballs, how many gumballs does your middle gumball machine have? So to do that, you're going to cross off one from each end, one from the low end and one from the high end. So cross off the 3, cross off the 16. And then cross off again the second number, and then cross off a third from each number, cross off a fourth dot from each side, cross off a fifth dot from each side, cross off a sixth dot from each side, cross off the seventh dot from each side. It looks like once you crossed off the seventh dot from each side, you end up with no dots left, which means your middle number sits between 8 and 10. And thankfully, that's easy to figure out. If there is not a middle number, then you find the mean of the two middle numbers. Well, the two closest to the middle were 8 and 10, and the number in between them is number 9. There's a way to find that mathematically as well, and we'll get to that. So let's do some examples where we find mean and median. The following data set represents the age of people in line to vote. So we've got a 27-year-old in line to vote, a 52-year-old, we've got a 72-year-old, a 68-year-old. Anyways, let's find the mean or the average age of the people who are voting. So to do that, we add up all the numbers, 27 plus 52 plus 64 plus 41 plus 33 plus 38 plus 42 plus 60 plus 72 plus 68. Once we add all that up, we need to divide by the number of people in line. There are a total of 10 people in line, so we divide by 10. So add up the top, which equals 497, divide by the bottom, which is 10. So the average age is 49.7. So of all the people standing in line, if you took the average age, it would be 49.7. What's the median? What's the middle number? Well, what we need to do is order the numbers from least to greatest. The smallest number here is 27, so I'm going to write that down and cross it off. After 27, I don't see 28. The next number closest to 27 is 33, so I'm going to write that down, cross that out. After that, it's going to be 38. Write that down, cross that out. After that, it looks like 42 may be it. Oh, 41. 41 is it, so we're going to write that down, cross it off. Then 42, write that down, cross it off. Then it looks like 52, write that down, cross it off. Then 60, write that down, cross it off. 64, 68, then 72. So do I have to divide? No. Remember, median is the middle number, so I'm just going to cross off numbers on both sides until I get the middle number. Hopefully I end up with the middle, but I won't because it's an even number. So cross off one at each end, cross off the second number from each end, then the third number from each end, the fourth number from each end, the fifth number, means I have no middle number, so I'm going to erase those and find what is the number that lies between 42 and 52. Well, this one's a little bit trickier than finding the number between 8 and 10. So what you do is you find the average or the mean. So take 42, you add it to 52, and you divide by 2. So 42 plus 52 is 94. Divide that by 2, and you get 47. You want to ask yourself, does this answer make sense? Is 47 between 42 and 52? Oh, yes, it is. So that's a reasonable answer. The reason we want to check before we write these down is sometimes people forget to divide by 2, and they just write down 94. No, 94 is the median. And they don't even think, oh, wait a minute, 94 definitely is not between 42 and 52. So you want to make sure you do those little checks as you're working through these problems. Number 4, the following data set represents the number of inches of snowfall within a 2-week period. So let's find the mean average first. We need to add up all the numbers, 2 plus 1.5 plus 0. Yes, we do have to include the zeros, so we're adding the zeros. 1 plus 8 plus 6 plus 0 plus 0 plus 0 plus 1 plus 2 plus 3.5. That's nice. I don't have to order them from least to greatest. Divide it by 14 because there are 14 numbers here. This includes the zeros. You cannot exclude the zeros. The zeros are an important part of the data set. So add up the top numbers. You're going to get 28. Divide by 14, and it turns out the average or mean inches of snowfall in the past 2 weeks is 2. Let's find the middle number. Let's order from least to greatest. I still have to include the zeros, so write down a 0 and cross it off. And then I don't go straight to 1 because I have another 0. So I'm going to write that down, cross that off. And I actually have 3 more, so write those down and cross those off. And after that, I finally have a 1. And before I go on to 2, there's a second 1 right there, so cross that off as well. So 2 1s to cross off, and then it's 1.5, then 2. then another 2, and then you've got, looks like 3, then 3.5, then 6, then 8. So once I have all those numbers ordered from least to greatest, cross off 1 from each side. 0 and 8, 0 and 6, 0 and 3.5, 0 and 3, 0 and 2, 1 and 2, 1 and 1.5. 2 numbers left, so let's find the middle number. What goes in between 1 and 1.5? A little bit trickier. So let's find the mean. Add 1 plus 1.5 and divide it by 2. 1 plus 1.5 is 2.5. Divide that by 2, you end up with 1.25. Ask yourself, does 1.25 go between 1 and 1.5? Yes, it does. So that is my median. Next, number 5. The following data represents the number of broken cookies in a test of 8 boxes of Girl Scout cookies. So it looks like when you buy Girl Scout cookies, there's a chance you may have a couple broken cookies. And this data set shows you how many broken cookies. So one person had 0 broken cookies. 2 people had 1 broken cookie. We had one person, one poor person with 7 broken cookies, another one with 6 broken cookies. Fortunately, it was only 1 with 7 and 1 with 6. Anyhow, let's find the average number of broken cookies one can expect when they buy Girl Scout cookies. So you're going to add up 0 plus 1 plus 1 plus 2 plus 4 plus 4 plus 6 plus 7. Add that up, divide it by 8 because there are 8 boxes we checked. The top equals 25. The bottom is still 8. So 25 divided by 8 is 3.125. So you should expect about 3 cookies or 3.125 breaks. That's the mean average. Now let's find the middle number. Now you saw what I did earlier, which was I can actually cross the dots. But in this example, I'm actually going to write the numbers down, which are easy because all the numbers are kind of in order already. So we've got 0, then 1, then 1, then 2, then 4, then another 4, then 6, then 7. All right, let's cross off the ends. 0 and 7, 1 and 6, 1 and 2, and we've got 2 numbers left. So what's the number between 2 and 4? Well, you know the answer is 3, but let's do it mathematically. 2 plus 4 divided by 2. 2 plus 4 is 6. Divide that by 2, and you get 3. And yes, 3 does seem to go between 2 and 4. All right, let's do the last one. The following data set represents the number of times the phone rings when callers contact Comcast cable customer service. So, for example, the number of times that the phone rings 3 times before a customer picks up, like 2 customers picked up by the time it rang 3 times. 1 customer picked up the phone after 4 rings, and 1 customer picked up the phone after 5 rings, 2 after 6 rings, so on. So how do we write this down? Well, we have actually, we're going to add our data sets. So we have 3, but we're not just going to add 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 3, but we have a second person who picked up after 3 rings, so that's 3 plus 3, plus 4, plus 1 person picked up after 5, 2 after 6, so 6 plus 6, 0 after 7, so you're not going to write plus 7. 2 after 8, 8 plus 8, 0 after 9, 1 person picked up after 10 rings, and 1 person picked up after 11 rings. So it looks like we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data. We're going to divide by 10. So if I simplify the top and add it all together, I get 64. Still need to divide it by the number of data pieces. And it looks like the average number of rings someone could expect is about 6, but I'm going to write the mean as 6.4. All right, what's the middle number? Order from least to greatest. So thankfully, these numbers are already ordered from least to greatest, but I'm going to rewrite it 3, 3, 4, 5, 6, 6, 8, 8, 10, and 11. And let's cross off the ends. 3 and 11, 3 and 10, 4 and 8, 5 and 8, 6 and 6 are the last 2 numbers remaining. What's the number that goes between 6 and 6? Well, it's 6. But let's do it mathematically, just in case. Add 6 and 6. Divide by 2. 6 plus 6 is 12. Divide that by 2 is 6. Yes, 6 is the middle number. So that is how you find the mean and the median. Go ahead and try some problems on your own. Good luck.